Some of you have asked about this question from exercise 1C.3, question 3g. Show that cosine over 1 minus tangent alpha plus sine over 1 minus cotangent alpha equals sine alpha and cosine alpha. Well, the way to approach this kind of questions is always to stick to one side, because it is much harder to start from the left-hand side and going down, and then right-hand side going down, and hopefully they will meet in the middle. It's very hard to control that. So what I would recommend is choose one side and stick to it, and utilize all the trigonometric ratio transformations to try to meet the right-hand side, right? So for this particular question, intuitively, I would start with the left-hand side. Why? Because with any tangent ratio, let's say tangent theta, remember that it has this relationship, which is basically tangent is a quotient for sine theta and cosine theta, right? Sorry, theta, not alpha. So if we remember that, the left-hand side, basically all I need to do is I want to draw a relationship between tangent, cotangent with the sine and cosine. So I just need to write first tangent alpha and cotangent alpha as a quotient of sine and cosine. So left-hand side would become cosine alpha over 1 minus sine over cosine alpha, right? Plus sine alpha over 1 minus cosine alpha over sine alpha, right? Let's remember, like, we're not going to touch the right hand side. We're going to stick to one side and see if after some simplification we could arrive on the right hand side. Okay, so once we do, what do we do? Okay, I'm going to clean up these two very gross denominators. And as we're cleaning, as in simplifying that, we'll realize that something interesting would show up. Okay, cosine alpha, right? Plus sine alpha over, we have two fraction lines here. Just to make things much clearer, make sure that you are writing different fraction lines, long and short, so as to distinguish it. Cosine alpha over sine alpha. Okay, so well, it's basically a too complicated fraction, but we know that if you have this cosine here and sine here, then basically the numerator, if we simplify it, so basically we can multiply to the top, right? Okay, so then the next step will become cosine squared alpha over cosine alpha minus sine alpha. Sorry, plus here. Sine squared alpha over sine alpha minus cosine alpha. And until this step, you'll be like, oh yes, we actually basically have the same denominator, because a minus b is the negative of b minus a, right? All we need to do is, what I would do is I would swap the second denominator to become cosine minus sine, and therefore change the plus sign in the middle. I'm gonna go to this side. So sine cosine squared alpha over cosine alpha minus sine alpha minus here, and I'm gonna swap these two. Therefore, there's a minus here. Cosine alpha minus sine alpha over sine squared alpha. Wow, 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 look at that. That's I think we're very, very close to the end. Because why? On the numerator, we basically have a difference of perfect squares, right? And on the denominator, we have basically part of a factor of difference of perfect square here, right? Okay, then all we need to do is, well, we can factorize the top. Just to save space, I'm going to write the factorization of difference of perfect square here. It basically is cosine alpha minus sine alpha multiplied by cosine alpha plus sine alpha. Right, so we can see that here is our common factor, and we can safely cross them off, as this was already a fraction. So we nicely arrived at the right-hand side, which is cosine alpha plus sine alpha.